basic definitions in Boolean algebra. Okay, so what is constant? So in Boolean algebra, 0 and 1 are called constants. Okay, so in Boolean algebra, 0 and 1 are called constants. Okay, next, variable. So what is variable in Boolean algebra? So in Boolean algebra, symbols other than 0 and 1 means other than 0 and 1 are called variables. For example, x, y, z, a, b, c. Okay, so these are variables. Next is monomials. So what is monomial? So the definition is a monomial is a term. A monomial is a term formed by the binary operation dot, okay, between the elements of a Boolean algebra, between the elements of a Boolean algebra. For example, x dash means only single variables are also monomial. Y dash. So if we use the dot between two variables, so this is monomials, means x dot y dash. So these are monomials, means only one variable x, only one variable x dash. So this is monomial, this is monomial. If we use the operation dot between two variables, so x dot y, this is a monomial, x dot y dash, this is a monomial. Also x y z, this is a monomial, x y dash z, this is a monomial. Okay, now polynomial. A finite sum of monomials is called polynomial. Okay, so the definition is a finite sum of monomials is called polynomial. Okay, for example, x plus y or x plus y dash plus z or xy plus x z. So a finite sum of monomials. So this is sum. This is sum. Means finite sum of monomials is called polynomial. Okay. Boolean expression. What is Boolean expression? So next is Boolean expression. Boolean expression means any expression built up from a finite set of symbols, each representing a variable or constant. Okay, so Boolean expression, any expression built up from a finite set, of any symbols, each representing a variable or constant, a variable or constant by applying the operation, by applying the operations plus dot or dash as suitably. Okay, so this is Boolean expression. Boolean functions. Okay, so what is Boolean functions? So any expression which is combinations of a finite set of symbols, that is a combination of constants and variables, by the operations plus dot and dash. Okay, so this is called Boolean function. Okay, Boolean function. For example, Boolean function of two variables x and y is equal to x plus y dash, or f of xy is equal to, this is x dash plus xy plus xy dash. So many ways to represent the Boolean functions. Okay, now we will explain fundamental forms of Boolean functions. Fundamental forms of Boolean functions. Okay, so first we will explain minimal Boolean functions. First is minimal Boolean functions. So what is minimal Boolean function? Minimal Boolean function, this function depends on variables. Okay, so in case of n variables, the product of all n variable, okay, taken together is called minimal Boolean function. Minimal Boolean function of n variables. Okay, for example, if we take two variables, okay, so minimal Boolean function for two variables. Example, minimal Boolean functions for two variables means, suppose x and y are two variables, then minimal Boolean functions for two variables are x. Suppose two variables are x and y, okay, then minimal Boolean functions for x and y are x y or x y dash or x dash y or x dash y dash. It means if we take two variable x and y, then total number of minimal Boolean functions are 2 to the power 2, means 1, 2, 3, 4. If we take three variable, okay, means x, y and z. There are two variable here, three variables. Okay, so how many number of minimum variables? So x, y, z, x dash y z, x y dash z, x y z dash. Now next x dash y dash z, x y dash z dash, x dash y z dash, 1 2 3 4 5 6 7, and x dash y dash z dash 8. So total number of minimal Boolean functions for three variables are 2 to the power 3, means 8. Okay, so in general, if we take n variables, so total number of minimal Boolean functions are 2 to the power n. Okay, so these are minimal Boolean function. Boole's theorem. This is very important theorem in Boolean algebra. So statement is there are 2 to the power n minimal Boolean functions in n variables. Okay, so this is the statement. Proof. Let b plus dot dash is a Boolean algebra let us consider a1, a2 up to an be n variables in Boolean algebra B. Okay, so let a1, a2 up to an be n variables in Boolean algebra n, and complement of a1 means a1 dash, a2 dash up to an dash are complements of above variables. Okay, complements of the above respectively. Okay, to form a minimal Boolean function, to form a minimal Boolean function, each variable can be selected in two ways. That is, either AI or its complement at AI dash. Okay, so since there are total n variables, so the number of minimal Boolean functions are minimal Boolean functions are 2 into 2 into 2 up to n times. Okay, means this is equal to 2 to the power n. Hence, the number of minimal Boolean functions are 2 to the power n. Okay, and hence proved. Normal form of Boolean function. A Boolean function of n variables is said to be in normal form if it consists all n variables. Okay, for example, let us suppose Boolean functions for two variables. Okay, so for two variables x and y, what is normal form? So normal form x plus y or x dash plus y or x plus x dash y or xy. It means this contain both variables x and y, this contain both variable x and y, this contain both variable x and y. It means any Boolean function of two variable consists all two variable. If Boolean functions of three variables, then it consists all three variables. So second example for three variable means normal form for three variables x, y and z. So this is x, y, z. This is normal form. Or x, y dash z. This is normal form. Or x, y, z plus x dash y, z. This is normal form. Means each function contain all the variables. Okay, so this is normal form of Boolean function. This is very important in future study of Boolean algebra. Type of Boolean function. Okay, so there are four type of Boolean function. First is disjunctive normal form, D and F. Conjunctive normal form, C and F. Complete disjunctive normal form, C, D and F, and complete conjunctive normal form, C, C and F. Okay, it means there are four types of Boolean function. One is disjunctive, second is conjunctive, and another are complete disjunctive normal form and complete conjunctive normal form. So now we will explain one by one. So first is disjunctive normal form. So what is the definition? So a Boolean expression is said to be in disjunctive normal form if disjunctive normal form in n variables suppose x1, x2 up to xn, if the expression is in the form of a sum of terms in which it means if x1, x2, x3 up to xn, n variables. So in case of disjunctive normal form is expression of sum of each term in which term is of the type f of f1 x1 dot f2 x2 dot up to fn xn. Okay, so in the case of disjunctive normal form, so D means disjunctive and here dot. So you remember D for dot and D for disjunctive. For example, so example for one variable. Example, variables here and here D and F. Okay, so we will explain for one variable, two variable and three variables. So for one variable, disjunctive normal form x plus x dash. For two variables, disjunctive normal form x y plus x dash y plus x y dash plus x dash y dash. Okay, for three variables, so here x y dash z plus x y z plus x dash y dash z. Okay, So for 3 variables, this is disjunctive normal form. So here, if we take x plus y dot x plus y dash, so this is not DNF. Okay, because here product. So we remember a Boolean expression is said to be disjunctive normal form if it can be written as sum of variables. Okay, sum of variables. Sum means product of sum. This is product dot x dot y dot z. This is dot x dash dot y, x dot y dash. Okay, so this is disjunctive normal form. Complete disjunctive normal form or complete DNF. Okay, so a disjunctive normal form means DNF in n variables which contain 2 to the power n terms is called the complete disjunctive normal form. Okay, for example, complete disjunctive normal form in 2 variables x and y is x y plus x dash dot y plus x y dash plus x dash y dash. Means how many variable? 2 variable. So total number of terms are 4. 1, 2, 3, 4. Means 2 to the power 2 is equal to 4.